I'll start the recording and start sharing the screen. Open Unity. Open Unity or not. I don't know what's happening here. Yeah, okay. Like I said before, even if we are just using this very scene yesterday without an issue, I tried to open it today, nothing changed, and Unity just decided that it will recompile, reload the scripts, and do whatever it wants to do. But
I think it makes sense because at least recompiling scripts, because they are just stored in file system, and in theory you can have it opened in some other IDE.
That's true. I mean, it should know that because
takes so long.
Yeah, it usually. I mean, it should know whether the scripts were changed or not, because that's actually the way how it recompiles when you're using it normally. So now, if I open the script in anything, it just watches whether the script file changed. So when I save it and go back, it only recompiles those which did change. So, but like I say, sometimes the things seem to happen at random. So, this is where we finished last time. We had a trigger, if I'm not mistaken. I made this large invisible trigger. And we had this first-person controller working, changing the color and the rotation speed of one of our objects, depending on whether I'm within the bounds of the trigger or not. Just to recap how this worked, this is this trigger object which has some shape, some mesh, but we made it completely invisible, so we turned out the renderer, and the box collider we kept, but instead of using it as a physical collider that would block our path, we turned it into a trigger. So now we can walk through it, but we get a signal at the moment we enter the area of this box collider mesh. Just one thing about the mesh and the box collider. The mesh is, I mean, a box collider internally, it's a mesh as well, but you can have different meshes for the visual representation, which is the main mesh, the one which is then rendered using the renderer, and a completely different mesh for the box collider. And the reason is that calculating collisions is a computational difficult task compared to just displaying some mesh. So in real games, usually your display mesh can be very complicated. It can be a model of a person or something with like in modern games, you know that there are like extreme details, almost photorealistic, and the same goes for the shape. But calculating collision on such a difficult shape would be too expensive. So the collision meshes are usually much simpler, like simplified versions of of the original mesh, a human made just out of a couple of cylinders and a ball for the head, and that's all. And it's good enough for detecting collisions in those games, because usually a collision happens when you're moving from somewhere to somewhere, and if it happened a couple of frames later or a couple of frames earlier, then the exact moment where the rendered mesh touched something, it usually doesn't matter at all. So our box collider is a trigger, and to use the trigger, we wrote a script here called trigger color. And that script had some new special functions in addition to the start function, and which just runs on the start, and the updates function which runs on each frame. These have those event signal catch functions called on trigger enter and on trigger exit. And as the name says, one is being called when you enter the trigger, and the other when you exit the trigger. We also put game object property to the script, and that allowed us to connect a different game object to the script and manipulate that game object later through the script and have it react on the trigger. Or of course it could possibly also manipulate the object in the start function or in the update function. We deleted the update function here because we don't need it. I mean, we don't even need the start function, just to show that the script doesn't need to have the start and update functions if it doesn't use them at all. So I would like to show three more things about the visual representation of these simple objects, and then we can move to visual effects, and we will try to apply those visual effects to some scientific data. So first thing is I wanted to show you something about transparency, transparent materials. And for that, we can use the trigger, for example. So now our trigger was completely invisible. Now, if I turn on the mesh render, it's just this ugly gray box. And I would like to make that box transparent, actually. So for that, we create a transparent material. So we go create material. And how do we do transparency? This transparency is in Unity is defined by something called a alpha channel, or like alpha value, and this alpha value is another property of the color. You probably know that in computer the colors are being mixed from three basic colors, from red, green, and blue. So it seems you need three numbers to define a color. In Unity, you actually always need four numbers to define a color, and that's red, green, blue, and alpha. And alpha is it's actually not the amount of transparency, it's the reverse value, the amount of opacity, let's say. So if our alpha is full at like 100%, or if you're using integer colors from 0 to 225, then fully opaque non-transparent object would have alpha of 255, and an alpha value of 0 is completely transparent object, so you cannot see it at all. And in the rendering pipeline, again, calculating alpha values is, or calculating the visibility of the objects which have some alpha value is, again, kind of difficult. So it's not being used by default, and you need to specify that the material should be rendered using this special alpha value aware pipeline. We will see that as well when we will be creating the effects. And when we will be creating the effects, you will also see how much more computationally expensive it can be if you use the alpha pipeline, or if you're just using the completely opaque pipeline. So now for this material, we choose some color, something we don't have there yet, or can we? Okay. Let's make it orange, and we change the surface type to transparent. We just leave the blending mode to alpha. The different blending modes we will probably try with the visual effects, but for now, alpha is the one which kind of should be doing what you expect. And the blending mode concerns if you have multiple transparent objects and you're seeing through all of them, then how they're layered behind each other, and how the light coming through them is calculated and displayed. So let's keep the blending mode at alpha and go back to our color base map. And you see there's this last value called A, RGBA. And if we lower the A, we're lowering the alpha. Here we see the resulting color shown with the checkerboard. So let's lower the alpha a little bit, and we will apply this half transparent material, for example, onto our trigger. And you can see now that the trigger became partially transparent. And if you don't have what? Blend mode? Okay, let me see. Yeah, we have to change the surface type from open to transparent, and then you get it done. Yeah. And now in the base map, you select the alpha value. So now our trigger is transparent, and we can change. We can. What could we do? I was thinking. Yeah. Okay. So I will enlarge my trigger so I can see more of it when I walk inside it. And so this is the new shape of my trigger. And now I will go back to the script which is attached to the trigger, and we will change the alpha value of the alpha value of our trigger box. Now, how to change the alpha value? There's many options, but I would say the easiest one is just to get the current color of the trigger, and change the alpha value of that color, or to create a completely new color with some specific alpha value. that can also show us how to create colors, not just using the keywords for those few predefined colors, but like to mix your own color exactly. So let's go back to the script, the trigger color script, and at the beginning we can save the original color of the trigger, and I've shown you all the difference between the public and private variables. Yeah. So let's save the initial color. Do that in start. You get the render of the trigger itself. So just like this, get component render, not material. The color. No, sorry, no, we wanted to save it. So this is what I want to do. Initial color. Yeah. And now on trigger enter, we will change the color to something else. Get component render material color, and set this not to a color defined by this keyword, but to something some custom color mixed from the individual channels. So we create a new color. I hate Visual Studio. So new color, and here they did this constructor for the color will take 4 parameters, RGB and A. So let's say a blue one would just be 0, 0. Now we can specify this as a floating point number between 0 and 1. So a dark blue would be something like 0.5. Don't forget that there are floating point values, so we need to put F at the end. And the alpha channel can be something like real transparent, so like almost completely transparent, like let's say 0.1 F. And on trigger exit, we can restore the original color. So get component render material dot color equals the initial color. I save it. Go back here. It will recompile without errors. That's great. And when I hit play, you can see that entering. Okay, this dark blue wasn't a good choice. So I'll try something different, something more visible.
White.
Yes, or just blue and green. So and something like this. can see that it changed to blue-green. I cannot see it when I'm inside of the trigger. And that's another thing you need to know about rendering, the rendering meshes, and that is that the mesh here, we cannot see it because it's somewhere in the mesh definition, and the meshes need to be, if you want to modify the mesh, you would need some other software. I mean, some specific meshes can be modified in Unity. There are usually those who are created by some specific Unity plugins. For example, there are plugins to generate specific plugins to generate terrain. You can basically just paint you have like you start with a flat plane, and you can paint depressions and hills on that flat plane, and through that you create terrain, and that's actually modifying a mesh, but in a very specific way. Otherwise, if you want a custom mesh model, you create it in some other software. So for example, for the art part, we'll be using Polycam, and then modifying the mesh in software called MeshLab. And there's also 3D Studio Max. That's like probably the best software for creating 3D meshes, but it's also extremely expensive. There's also Blender, which is completely free, and it's also an awesome way to create meshes. But it's, I mean, both 3D Max and Blender are kind of difficult to learn. Yeah, that's the most common options, well, like general options, if you have any idea of what you want to create. But
can you please show the script once again? Or...
Yes, yeah, sure.
I'm not sure, but I can.
Yeah, I will keep the script on, and so the mesh is a list of vertices and their connections, and that's what in the end defines the shape of your object. But there's one more piece of information stored with the mesh: vertices, the edges, and something called normals, or a normal map. And normals are attached to each of the surfaces, which is defined by the vertices and edges. And in the 3D rendered meshes are always made out of triangles. So even if your software, in your software, you define a surface that is made from more than 3 vertices, it will always get cut into some triangles. So that the smallest surface defining the mesh is always a triangle, and each triangle has another number, another vector attached to it, and that's the normal vector. Or in the end, it's actually a number, and there's a way to calculate the normal from the orientation of the vertex itself and that single number. And that vector tells you which side is the vertex oriented, and it also provides a way to simulate curved surfaces. So by combining normals, which are not actually vectors normal to the surface, because for that you wouldn't need to calculate anything. If you have a surface, you already know it's normal, you just don't know which way it's pointing. So you could get away just with the number telling you the length, maybe, if you need it, but basically with just 1 or 0 telling you the direction. But normals are also used for defining curved surfaces, because that's something you cannot easily represent just using those triangle meshes. And so the normal points into one direction, left or right, if or up or down, or like one direction away from the surface. And if you're watching your object and you're watching against the normal, then you see the object and there is something being rendered. If you watch it from the other side, then you don't see anything, because for the graphics card, nothing is to be rendered if its normal is not facing the camera, or like if the direction of the normal is not intersecting with the view cone of the camera. And that's exactly what happens when you enter inside inside the trigger, because I can see it from the outside, because the normal is pointing outwards. But if I go inside, I can see the color changed in the scene editor, because the color really changed. But I cannot see anything, because inside of the trigger, my normals are pointing away in the wrong direction. This can be probably changed somewhere in the mesh renderer. I'm not exactly sure, because it's not the way you usually do it. The way you usually do it is you don't really enter objects and try to see them from the inside. If there is something that should be rendering as a room, for example, then you build the room out of walls, and the walls have their normals facing facing the inside of the room. So just to be aware of that and not to be surprised when your normal suddenly when your object suddenly disappears like this. So that also means that changing the color of the trigger is not that interesting to us. So maybe we will try to change a color of one of the other objects, um, or the transparency of one of the other objects. So let's try with the sphere, for example. Yeah, the sphere is here. It's called something in my script. So instead of changing the color of the trigger, we will still save the original color we put to the trigger. But what we will do instead is that we will change this color to the one that was attached to the trigger, and we will keep the trigger transparent. So you give this material the color that was initially here when we enter the trigger, and when we exit the trigger, yeah, we can leave it with, or instead of you, we will change it to this new color we defined here. I delete everything that was about the trigger. So now this is kind of a convoluted example, but now the initial color, the color that we will use as maybe I shouldn't call it initial now, but the color that we will give to the other object is stored as a parameter of the trigger, and it's actually being read from the trigger from the trigger's renderer, and that color we will apply to some different object, to the object we connected to our script here. So let's see what happens. I enter the trigger, and you see that the color changed to this orange brown, but it's not transparent. And the reason is that I've defined a transparent color, but I've applied it to a material which is not transparent. Yeah. So even if I wanted the transparent color, if I select the sphere here from the list of objects, I see that it's no, not this sphere. This sphere. It's still it shows the orange color, but it's using this material. I changed the color of the material, but the material itself, except for the color, got unchanged, and the surface type has not changed. So that's why I cannot see the transparency at all. If I wanted to see the transparency, I have to modify the material, not anything. I mean, like there's nothing here in the properties of the sphere. I could modify. I have to go here to the material definition and change the surface type to transparent. Now, if I keep the initial color non-transparent, there nothing happens at the start of the scene, and now it works. Now it's giving me this half transparent sphere. So this is all I wanted to say about colors. So transparency is added as alpha channel. A color is then defined by the red, green, and blue components and the alpha channel. But the alpha channel has no effect if your material of or the visual effect, as we will see soon, if it doesn't support transparent rendering mode.
And why is it made so?
Performance reasons.
Yes,
yeah. It's just that it's
makes sense.
Yeah, there's a lot more calculation you need to do if something is transparent, and
even if the parameter is
yes,
100% alpha.
yes. You could potentially of course see beforehand that the parameter is 100%, and then switch to the opaque rendering mode and just ignore those changes. But since these things are being baked on the CPU and then sent on the GPU, then if it might be now, it of course depends on the exact algorithm that's doing it, but it might be difficult to change it, to change the rendering intent later when it's already uploaded and running on the GPU. Okay, last thing I wanted to show regarding the visual representation of our objects is yeah, okay, no, I'll skip this. It's not important. Let's get to the visual effects right away. So I will keep our trigger, just make it transparent. So I turn off the mesh render, and we will create a new object of a new type and basically move into a very different way of working with Unity. And for some, this might be a completely new thing, and that's we'll do so-called visual programming. So programming languages, as we know them, will look something like this. You write commands, and like the interaction between the commands is like specified in whatever the commands mean. And using this, you can write. Here we were writing algorithms, changing colors, changing some numbers, some parameters like this rotational speed, etc. And when your computer is rendering a 3D scene, it's actually running an algorithm on the graphics card, and those are specialized algorithms, but they can be written in very similar or sometimes even the same languages as the ones we can use on the CPU. And those languages have the same richness of expression. So anything you can write in language like C#, anything you can express in language like C#, you can also express in one of the languages using for the GPU, but it might be more difficult. That's the difference between different computer languages, that you can usually do anything in any language, but it might be extremely complicated if you're not using the right language for the right task. And on GPU, these languages are usually called shader languages. A shader is a piece of code originally that was intended to take some data and decide how to render the data on your display. But the shader language has the same general possible richness of expression as any other computer language. So some people try to exploit this property for example, using graphics card for doing scientific computations, for example, without actually displaying anything, but just really doing calculations. And there's also this other way where people are trying to get the ideas from the, let's say, traditional or like more well-known programming languages into the shader languages, so that you can manipulate your initial data in any way you want before you display it. And you can do that straight on the GPU. Now, the shader languages can get a bit difficult to understand, and it's another language you would have to learn. And it's also a completely different approach to, for example, working with memory and all that stuff. So I will not going to show you that, because it's, like I said, it's too difficult. It's unnecessarily difficult for our purposes, because Unity, and that's the main reason I'm using Unity here. Unity has a special way to express the shaders and those general purpose shaders called compute shaders, which just do some general purpose computation, and to express them visually. So you don't need to learn a programming language. You just need to think about the algorithm itself, and then it's all point and click. And this facility is kind of new. I think they introduced it in 2018 or maybe 2019, and it's still evolving. That's the good thing is that they're adding new features with like almost every Unity release. The bad thing is that there's still a lot of things that don't work the way you would expect them to work. Some incompatibilities. So, for example, if you take this visual effects system called VFX graph, if you take this VFX graph thing and try to export your project as a WebGL project, because, like, for example, the thing we made now should be just exportable to WebGL. That means you export it, it gives you a web page. You can upload that web page to a web server, and then play this very same game as we played here, to play it through the web browser. The visual effects, for example, do not support that, and it will support it at some point because they've changed the approach of how to implement it many times over and over again. They might have some prototype for some web compatible prototype ready later this year, but maybe yes, maybe no. So yeah, this is what I wanted to tell you, that up until now you could also take your creation, your scene, and publish it online so that people can like play it online. From now on, what I will show will not be available for the web for web compilation, at least for a year, I would say. But you can still use it on all the computers, and it is compatible with most modern phones. Again, modern phones. Some older phones which don't have a fast enough GPU will not be able to display the VFX graph. Actually, because of the very same reasons that it cannot be displayed on the web. So, oh yeah, and one more thing. If anyone here is using Linux or a Mac, then you might need to make a small setting change to see the effect as well. Maybe yes, maybe no, we'll try. So we'll try the basic effect, and if it doesn't work for you, you will tell me, and we'll have a look. So like I said, we're gonna be, oh yeah, sorry, I should have turned the page first and to actually read what I have prepared. So, and in order to add the visual effect, it's gonna be some other object, but the visual effect is not the visual effect package is not available by default for this URP template. So we need to install it. We need to install it from the package manager. We don't need to get it from the asset store because it's already included in the basic Unity assets. So we just open the package manager from window package manager. We go to Unity registry. And down here in Unity registry, we should find something called the visual effect graph. So we install the visual effect graph. Okay, so hopefully it's there. And now we add the visual effect to our scene. You see that there's a new menu item that appeared called visual effects, and from visual effects we take visual effect. So you can give it a name, VFX1, and if I double click on the object, so that.
But did everyone install it? Did it work for everyone?
Yeah, I installed.
Okay.
Yeah, sorry, but I mean, like, of course, if If something doesn't work, just tell me. So if we
So for
open,
me, it's still it's being installed.
yeah. Okay. Mhm. Like meanwhile, those who edit the effect, you can explore how it looks in the scene. You probably won't see much.
I see visual effect graph folder, yes. And what should I do to move it on the hierarchy?
You edit as a new object. So right click to the hierarchy, and here you should see visual effect, visual effects,
Okay.
or
Okay.
yeah, or here.
Yeah, it works as usual visual effect. Yeah, thank you.
I have it.
So you installed it?
Yeah, I've installed and I've created a visual effect on our scene.
Yeah, fine. So if you add the new visual effect, it will appear in your move it somewhere so that you can see it better, and it will just appear as this lamp, and it's not actually doing anything right now, but you will also see this those little play controls where you can play or stop the effect, but since we don't have any effect there right now, there's nothing to play or stop. And if you go to the inspector, you see there's this component called visual effect. And the most important part right now is the asset template. So the visual effect game object is just a placeholder that can display the effect and control it, for example, how it plays, stops, and etc. But what we really want is to create the effect itself. So for that, we create a new asset, new VFX graph. We can do it either from here and give it some name instead of new graph, VFX1. And if I do it, this kind of window will open. The other way to do it would be from the asset window to right click and create, and somewhere here, yeah, under create visual effect, you would create a visual effect graph. And this is how it looks in the assets window with this icon and the name of the visual effect. In the inspector, there's nothing really interesting. It's mostly some low-level stuff. And if you see this initial visual effects, this is more or less what you should see. Those little color calibration targets and
Like bubbles.
yeah, it looks kind of like bubbles. And yeah, coming out of this single spot. So now I go back to the visual effect graph itself. So either I double click here in the assets, or if I found it through the scene, go to the visual effect object and find the asset template and click edit. And I should be greeted with something like this. And this is the basic graph for our visual effect. In this window, you can zoom in and out with the mouse wheel, move around by holding the mouse wheel and grabbing the just grabbing the whatever is on the display, and with the left mouse button you can select different parts of the graph, and with the right mouse button you will create new nodes for the graph.
Excuse me, how to get to this window? I should type it somewhere.
So if you created the new effect,
Yeah.
you need to create a new effect graph for that effect.
Ah.
So either here through asset template, there if I delete this, then in asset template I should have the button new, and if you click new and give the effect a name, it will create a new effect for you. The other way was to go from here, go to create visual effect graph.
Yeah, I made it.
Yeah, okay,
so
okay. So then you can connect the visual effect graph to your visual effect like this, for example, and then you edit the graph either by
and then
clicking
okay.
here or by double clicking on the effect you want to modify here.
Yeah, I got it. Thank you.
So yeah, I will explain the concept of the visual effect graph. We will make a slight modification and then we'll have a little break. So the visual effect graph is actually a system that that operates with particles. And particle is just something that has a position and some other properties. But from the point of view of the visual effects graph, all other properties of the particle are completely equal because they're just numbers. The important thing is the position. That's the one which is somehow special because that defines where the particle exists in our scene with relation to the initial coordinate of the graph. And all the other possible properties have to be somehow interpreted through the graph. They don't have any meaning by themselves until we give them meaning. And the particles so the particles are actual objects living somewhere in the memory of the GPU. They are created by the graph, and later when we will want to use the graph to show our own data, we will not be like creating the particles from our own data. The particles will be created by the graph, and our data will tell the graph where should it move the particle it created. It's just a I mean, it's good to be aware of this notion that even if you will then import some of your data, the data isn't actually defining the particles. It's the particles are defined and created by the VFX graph, and then you can move the particles that the VFX graph created to some other coordinate that you want, that you specify. So the VFX graph operates as a pipeline top down here. That's the main pipeline which creates the particle, modifies it somehow, and then displays the particle on the screen. And this pipeline can be modified by those compute shaders, and which will create a graph which will then appear on the sides of this pipeline. We'll get to that later. The very beginning of the pipeline, the graph creates the particles, spawns them. That's the first part. Then they can, then it will give them some initial properties, initialize. Then after they're initialized, they can be so after the particle is created, it can be initialized. That happens once after the particle is created. Then in update particle, this is something that that happens at each frame again. So the particle can, its properties can be changed at each frame through this part of the graph. And in the final part of the graph, there's this output. So this is after your particle has been updated, you can still make some other modifications, mostly concerned with the way the particle is displayed, with the way the particle is rendered to the screen. And in the end, it's rendered to the screen. So let's explore in detail what we have in the default effect. So first, there's something called a spawn system, or the spawn, just spawn. So that's what creates the particles. Now, there's many different spawn systems, and this one is just constant spawn rate, and that means that it creates this number, now 16 particles per, and I don't know if it's per second or just per some predefined amount of time. Okay, sorry, I don't know what predefined amount of time it is, but usually you just try and see what works, or you have some very specific requirement. For example, if your input data has some, if you know the number of the data points in your input data, then you will want, you might want to set this to that exact number.
By experimenting with it, it seems like it's per second.
Yeah, okay. Thank you. Makes sense. So so now we're spawning 16 particles per second, and we put them, and the spawned particle is nothing, is just a piece of memory that holds the particle. Now, we need to give it some initial properties. For that, we moved to the initialized particle part of the graph. Now here you see there's something called capacity, and that's the reason is that I can spawn the particles like pretty fast, but I need to reserve the memory for the particles on the GPU. I don't need to fill up the whole memory. But in this case, since they're spawned 16 per second, in my memory here, I can only hold 32 of the particles. Then in 2 seconds, I will fill up the memory completely, and no new particles would be spawned. But this is important because this really reserves the physical memory on your GPU. So if you cannot make this number arbitrarily high, because then it just wouldn't fit the memory of your GPU on your computer. So, but it needs to be high enough so that it can hold all the particles you actually want to see. Then you give the particles some initial properties. So here, for example, this gives them a random velocity. it says per component. So each of the velocity component will be a random number, and the bounds for this random number are specified here between A and B. So the random velocity in the x direction goes from minus 0.3 to 1.3, so it can move both ways. But in the y direction, it only moves up. They only move upwards because the lower bound is 0.0 and the upper bound is 1. So if you want to move them, I don't know, just to one side, for example, then you would change the bounds here. And now, as you see, the VFX graph opened as a new tab. So if I have the VFX graph open, it's difficult for me to see the modifications I've made. I cannot see it in the scene. So now this, just like move it the way you want on your computer, what's most comfortable for you. I will probably move it down here or to the side. I don't know. Yeah, okay, no, I know. I will move it to the same part where the inspector is, and just rearrange my windows. But I mean, like, you see that the best would probably be to have a second monitor. Yeah? But this works well enough. So here's the preview of my visual effect. And if I, for example, modify this component of the velocity, that it starts with 0, and here it starts with 0, I need to save the graph, or maybe I don't need to save the graph. No, it was there immediately. Or I can also.
It seems like it's changed on the go.
Yeah. So I can also, let's say, to make this from 0 to 1, and you can see that the particles are now being emitted just in like in some other direction defined by the vectors. If I would change the bounds so that they're not they're the same, they wouldn't be really random. Everything would be 1, 1, 1. Then the particles are emitted just in one straight line and at some degree. If I allow -1 here, then they can go up or down. Now, so from some perspective, this should again look like a single line, but I'm not gonna. Which one should it be? No, because it's under 45 degrees. So yeah, like here. So they're emitted just in like one plane. The other part is this set lifetime. So this is how we are able to spawn 16 particles per second and store them in a system that only has capacity for 32 particles, and that's, we give the particles some finite lifetime. And this means just that if the particle is assigned some lifetime, after this number of seconds elapses, the particle is destroyed, deleted from the memory, and the capacity occupied by that particle is freed, and you can spawn a new particle into the particle container. And here again, the lifetime is random, between 1 and 3 seconds. If I put it into 1 second, 1 to 1, then it's not really random, it's just 1 second. You can see that all of them are deleted exactly after 1 second. I can give them a longer lifetime, 5. They will fly away faster, but the replacement, it will look like they're going in bursts a little bit, because I spawn the 16 particles and now I have to wait 5 seconds until I can spawn another 16 particles. And in the end, the update particle, we'll get to that later. So this is more like the basics. The particles have some lifetime, some velocity. But I mean, the velocity, of course, can be 0. And I can completely disable any of those parts using this check mark. So if I remove the velocity, now what happens is that the particles are just being generated at coordinates 0, 0, 0. They're not moving anywhere, and they will just cease existing at some point, and new ones will be generated. That's a completely useless effect. If I would disable this lifetime setting, then since they have some velocity, they would just fly away and disappear. And I wouldn't have any new ones because my my bounds were filled. And the last part is that this tells me what the particle will look like in the end. And the output here, it's a so-called quad, and quad is a you can think of it as like a sprite, basically. If you have a piece of paper, a sticker or something just floating in the air, so it can be, or the face can be oriented to you or to somewhere, but it's like basically just a 2-dimensional object which has or can have a texture. And the texture, the default texture used here is this color calibration target, which looks a little bit like a, I don't know, like hourglass, or like a clock or something. But it's actually defined here in the part which says main texture. So instead of, let's change the texture first and get something that actually looks like an effect and not like an error. And so we click on the texture, and here we see different textures that are available to us. Those are coming from the VFX graph textures, and actually no, I don't like those. So no, because yeah, that found the default texture. Click on the on this circle icon, and that shows you all the textures that you have in your project. Now you can either create your own texture, or in this case you will find a texture called default particle, but not this default particle, but default minus particle. Should be somewhere near the end of the list. Hopefully, should look like this. And you see that default particle texture already looks like something something you probably might have even wanted to have there. And those things that go over life, I will show that later. And the last part, we can change the color, for example, here. And here in the quad, you can see that we're encountering the alpha blending again, here and here. So for my particles, if there should be some part of some effect, like of fire, for example, or something like that, then you want to see through them. So very often you will use the alpha blending mode for the particles here. Then the color will be specified as color or color and alpha. And if I click here into my color selector, because this is not set color, it's set color over live. But I'll show that after the break. So now let's just use both of these small arrows at the bottom. If you click it, it tells you which color is at this point. So let's say you give them red, and on the other side we make them yellow, so it's kind of like a hot fire. And if I close it, you can see that the particles are initially starting as small red ones, and as they propagate, their size increases and their color changes to yellow. The increase of size is actually here in set size over life. You can save the graph, Control S, or like click save here, and then you will have it back here in the asset list. And since we are for the scientific part here, you can already see that maybe if you don't set this random velocity, but instead modify the position of the particle to be at some exact spot, then if your data is made of particles or vectors, because that particle is defined by its coordinate vector, then you can already use this to visualize the data. But I've also told you that we will be working with volume data, and it's maybe not really obvious how can this be used for volume data. So for the volume data, what we will do is that we will spawn the particles, and we will move them to positions along the just the Cartesian 3D grid. So in each point of your grid, of your volume grid, you will have a single particle, and then we will modify the way we output them, so they won't be quads, but they will be something else. They will be cubes, and if each of your particles is a cube and they're arranged in a uniform grid, then visually they will create that Cartesian volume grid, which is kind of like a natural representation for this kind of volume data. And then we'll play with the different ways of representing it some more. So I would say a 10-minute break now.
Yep.
So let's continue at 11:40. Oh yeah. First, if there are any questions before we start the break. No? Okay. So 10-minute break. Let's continue at 11:40. Okay, I'm back. Okay, just 1 second. I need to connect my computer. My laptop has run out of battery, and I have some stuff on it that I will upload then. Cable. Okay, let's continue with exploring the VFX graph. So last thing we did was setting the color of the particle, and we use this set color over life. So it does what the name says. Over the lifetime of the particle, which was randomly selected between 1 and 3 seconds in this case, the color is changing according to the gradient, which is defined here. Back to the gradient, you can change the color, and you can also change the alpha channel of the color. The alpha channel is the alpha is specified with the arrows on the top, and you will see that if you move the arrow, it changes the gradient. So now at the beginning of the lifetime, the particle is almost invisible, or if I do it like this, yeah, that doesn't visually change that much. But of course, you can you can do I can make them mostly red or mostly yellow if I move the bottom arrows. Similar to this change color, there was this set size over life that's defined as a simple graph, and I can move. Now they start as large, and their size decreases in time. And if I right click on the graph, there's this, there was this add key that adds this key point, and the interpolation goes between the key points. So now I can make them go large in the middle and then small again, modify this curve. This is a Bezier curve. If you've ever worked with some vector graphics editing program, you've probably encountered those Bezier curves before. So this is the basic workflow for the lifetime of a single particle. But you've noticed there's some other parts in this VFX graph editing window. One of them is this so-called blackboard. You can turn it off and on if you click here on the blackboard button. And on the blackboard, you can have variables that are visible outside of the graph, and they can be connected to your other game objects in that you have in the scene. So, for example, we can add a new variable to the blackboard here using the plus button. Now, we need to select the type of the variable we want to add. So let's say we want to add a number, a float. It will create a new float. If we click on the arrow here, it asks us whether it should be exposed or not. So if it is exposed, it's visible to the game objects here. If it's not exposed, it's just visible internally while editing the graph. You can give it a default value. So let's say we put 3 there, and a tooltip, that's just some description that will be displayed when you then see the variable in the inspector. We can also give the float some name. So let's rename it by right-clicking and clicking rename, and let's call it max lifetime, for example. So now our new float is called max lifetime, and it has a value of 3. And you've probably guessed that since I've called it max lifetime, I will somehow want to influence to connect it here so that it modifies the maximum lifetime of the particle. And there's 2 ways to do that. One is to just grab the variable from the blackboard and drag it here onto the main editing board, and you see this little dot here and here, and since I said it will be a graph, graphs are connected by edges, so we can create an edge by clicking here, holding the button, and connecting it to here. Now, nothing changed because the value stayed the same. The value was 3, the default one. And now if I save the graph, save, and I open the object and switch to the inspector. So in my inspector, I now see that the visual effect, okay, yeah, it has the asset template. That's what we did before. But at the bottom, there's a new part, and that says properties. And this is a property of our visual effect graph. And this is where the exposed properties from the blackboard will appear. So we have this max lifetime here. I can change it to 1. And you can see that the lifetime decreased. I can change it to 10. Then my particles will exist for 10 seconds. And this property is accessible also from scripts, which we define in our assets, scripts which are run in different parts of the sample scene. So this way, the visual effect can communicate with the rest of the scene. So coming back to the VFX graph itself, what are the other options we can, or what else can we do with our particles? So, I said that we can, for example, change the output type, the visual representation of the particle, and the graph, a single particle can have multiple multiple representations. The initializing phase, the spawn system can be connected to multiple initializers. The initializers can have, I'm not sure if they can have multiple updates, not important, but this is the one you use the most. That's from the update, you can have multiple representations of the particle. They can be active at the same time, or you can just delete this line connecting the update particle and output particle, selecting and clicking, pressing delete. Now nothing happens because I've been updating the particle, but I'm not displaying it. I wanted to connect it to a different display mode. So I click here. Okay, I'll enlarge it a little bit. Again, I click on the connection point here and just make the connection to the empty space, and it will give me a list of outputs I can connect here. So we've already seen output particle quad. There's also output particle point, which is the fastest way to calculate the particles. So if you need a lot of them, then you can display them just as points. Of course, the points don't have many options of modifying the way they are displayed, but they're very easy to calculate. So we can use a lot of particles, and we can use, for example, output particle mesh. And if we're using a mesh, then the particle will have some predefined shape. The shape's defined here in the parameter mesh. So now there should be capsules. We can also select something else. Again, clicking on the clicking on the circle. Let's turn them into cubes. So now they're cubes, but we can't really tell they're cubes because the texture it's displayed on the cube is this shape. So we select some other texture, and again, if we scroll down in the list, we should find another texture which is called default particle system, and it's just white, just a white, small white picture. If we select, oh no, it has an alpha channel. Sorry. So what I want to find now is a texture that's just pure white, white box, simple white picture. And it's probably okay, it's not in the default, so I will have to get it from somewhere else. Yeah, okay.
What is that default on the left? Default color or something? Oh no, it has transparency.
Yeah, okay. The default check. Yeah, okay. This is this will work. This will do. Thank you. Yeah, I forgot that. Okay, normally if you want a cube that just has a single color, then you would put a texture which is of a single color on the particle. And since the color can be modified also, then the best way to do that is to have a texture which is just pure white, just a white picture. And I forgot that those are not part of the default assets, that I always copy it from some of my older projects, so I can use it. But now if we scroll, if we look around in the scene, we can see that our particles are actually small cubes, yeah, with some alpha channel. So we can keep the quad here for reference, or we can delete it. And now this is just showing us the default cube with the texture we've defined. Maybe we want to modify it somehow. So for example, we might want to modify the size of the particle, because that's what was lost here. So here it says press space to add blocks. So I click on this segment, I press space, and it gives me a list of blocks, which are some active functions that modify the properties of the particle. And from the blocks, I can select size, for example. Output. No, it's in the under attributes. So as you see, I cannot find it because I don't remember where it is. I wanted to change the size. That's the only thing I remember. So I can use the search bar and put size, and it gives me some options how to set size. I can set size by speed, so yeah, or over life. That's what we've seen previously. I can set a random size. I can also just set a specific size using this set size attribute. So I will add the set size attribute. It already has some predefined size, 0.1. I can change it to 1, and now my cubes are huge. I can change it to 2, 0.5, and of course I can also make the size modifiable from the blackboard. So that's another way to add variables to the blackboard. I go to the unconnected connection point here. I drag it to the empty space, and it asks me what node should it create, what node should it be connected to. So I can select property, and I thought I could create property from here. No, okay. Sorry, so no. I have to create the property first. So I go to the blackboard, go with plus, float, rename the float to size, and it will get some default value. So let's say our default will be 0.5. And now that's what I wanted to show. But now if I go from the unconnected point, just here from the list of properties, I can select size, and now the size of the particle can be controlled from some script from the outside.
So the VFX block which we create, it's mainly mostly used for just creating, defining some variables, maybe some other stuff you will show later. But it's not incorporated directly into the pipeline. You just create a bunch of stuff inside of the VFX, and then you connect it to the general pipeline.
Yes and no. The general pipeline is this.
Yeah, because each time, for example, we use variable, we drag it out of the VFX. It's like we have this box, and from there we
no. This whole thing, okay, I get it. This whole thing is the VFX. Yeah. So this is just one part, and that's the rendering pipeline of the VFX. And those things are not really outside of the VFX. They're still part of the VFX, but they are not part of the rendering pipeline. There are modifiers that are calculated on the side, and then the results of those modifiers can be connected to parts of the pipeline. I will show that now. So let's say we have this size, okay, configurable from the outside, but we want to do something with it. and we want to start building those compute shaders. We want to start applying algorithms which will modify the size, for example, in this case. And normally you would have programmed this in a programming language, and here in a compute shader programming language, but here we do it using this visual programming language. So, for example, when this number is coming from the outside, it's configurable by the user because he selects the size he wants to use in the inspector, and I want to modify it. I want to double it, for example. I create a new node. So right click here and create a node. And all the arithmetic operations can be expressed as nodes in the graph. So let's say my node will be, I want to multiply the number. So I get a node called multiply. I start writing multiply, and it gives me multiply from operator math arithmetic set. I could also go there by clicking to operator math arithmetic, and here I have a lot of arithmetic operations. So for example, multiply, and I want to multiply, let's say I want to multiply it by 2, and I want to multiply the size by 2, and then set that as the size. So I can disconnect this, so I can delete it. I delete it, and then this tells me that I'm multiplying number A with number B. So I connect size to here. It will tell me, okay, it's getting 0.5 in because that's coming from here. That's coming from the Blackboard definition. Multiply it with some other number. So let's say multiply it with 2. I can write the number directly here. Now I'm multiplying size by 2. And then the output I can connect here. And now it knows the output is 1, so it sets size to 1. And with this way, I can create equations. So I can, let's say I don't want to, this number maybe, I want to set the size to be random, yeah? It's kind of difficult to navigate through the graph, so I will turn off the Blackboard, but you can always access it through this button here. So let's say
Which button? Which button?
Oh, there's a button called Blackboard, like at the top of, yeah, here. And so I want to add a random number here, and for that there's already exists a pre-made node. So I again drag to the empty space and I search for random, and it gives me a random number. So I select a random number here. The random, this gives me a random number between 0 and 1. And you can see that now already the particles are of a different size, between 0, the small ones, between 0 and 0.5, because I'm multiplying a number between 0 and 1. I'm multiplying it with this, with the initial size, with the number I'm getting from the outside.
But why do it always block schemes?
Hmm?
Why make it always block schemes? I mean, what was it always like that with VFX, that you were programming it with these visual blocks, or it's just
No. Originally, I mean, the VFX graph is a way to program compute shaders using this graph system.
So just a simplified way.
Yes.
Okay.
So because okay, I can show you compute shader example. This is even like how to write it in Unity, but a tiny bit more complex compute shader would look something like this. And yeah, this is just like some computation you're doing on some of your inputs.
Okay.
But it can get quite complicated. Yeah.
I see.
So here you do the same thing, but using this graph system. Now, of course, yes, like if you need to multiply or if you want to add something. So let's say now, since this is giving me a number between 0 and 1, let's say for some reason I cannot modify the minimum value here, but I want my particles to have some minimum size, so I can create a node which adds a number, and I will add 0.1. So now I'm getting numbers, yeah, and connect it like here. And I'm basically creating like very basic equations, which I could write easily on one line. And yeah, it gets kind of weird for those simple things. But for some more complicated things, it's actually, I would say, preferable to use something like this. Okay. Now I have to open my laptop, and I'd like to give you the scripts that we can use for the scientific data. So, like I said, sorry, because the laptop turned off, I have to open everything again, Unity, etc. So, like I said, the particles are initialized here, and their positions at the beginning, the position is 0, 0, 0, and here we can see them move because they have some velocity. If I disable the velocity, the particles will be spawned in one single at this one single point. What we will want to do is to move the particles to specific points that are defined by our input data. And for that, first, let's say our particles have 0 velocity, but we want to set them to some positions. Let's start with some random positions. So I will add a block here to the initialized particle block. So I go to initialize particle, click on it, press space, and go to position. And I want to set the position somehow. And we'll use just the, is it this one? No, sorry. Setting the position from attribute set. Again, I can just search here, go to position, and what I want is just to set position, nothing else. Now the position of each particle is 0, 0, 0. Of course, I could modify it here. You can see the new particles are starting to be spawned at -1, 0, 0. And yeah, then because I had the old particles still within the lifetime at the original position, it took some time for all the particles to reappear, because first these have to die so that the new ones can be spawned into the new position. But what I wanted to do is to give them random position. So let's say first we just modify the x variable. Again, the operator will be a random number, and if it's something between 0 and 1, you can see that in one of the coordinates, they being spawned on the line. Yeah? And if I attach a random number to each of the positions, you can still see that that it's still being spawned on the line, but just like under a different angle. So this is something you need to know about random numbers. If you didn't already know, random numbers in a computer are usually not really random. They're more precisely called pseudo-random numbers. And that's because they are generated by an algorithm, and an algorithm always produces the same output if you give it the same input. And they're called pseudo-random because while they are not random, while they're being produced by an algorithm, the algorithm is always the same. But if you look at them from the outside and you didn't know that they were generated by the algorithm, they look like if they were generated at random. The issue is that if you use the same algorithm with the same inputs, it will give you the same outputs. So if I'm using those 3 random numbers, but those random generators have the same inputs, the sequence of the numbers I get here is the same as the one I get here and the same as the one I get here. So my XYZ coordinates are now always the same numbers. X equals Y equals Z, and that's why it's on the line. If I want my generators to give me different sequences of numbers, I need to give them different inputs. And for the generator, this input is a single number called a seed. Seed is a starting number from which the generator generates the sequence. So if my generators have all 3 of them have the same seed, then they're generating the same number. If I really want the numbers to be random, I need to give different seeds to each of these generators. So let's say this one will be seeded with 1, this with 2, and this one with 3. And now you already see that and let's also increase the position distance. Let's say set the maximum to 2 in all cases, so that they're spread more in space. And now the positions are set to some random number between 0 and 2, and each of the position component is set to a different number, different sequence of numbers. If I save my graph and go back to the scene, I open the inspector with my VFX graph and set the size to something a little bit smaller, like, I don't know, 0.2. And now it's well visible that my particles are just being spawned into random positions over the time in all 3 directions. And for the scientific data, we don't want them in a random positions, but we want them at some specific positions defined by our data inputs. If there are any questions to this, please ask me, because now I have to quickly find the data example and copy the files I wanted to send you, because yeah. Okay. What you want to do? Like, So you would like to do another connection, or you want to move it? You need to use the middle mouse. So in this case, probably like click with the no. No, okay.
Without mouse, I
Yeah.
I had a look around, but I just zoom out and then zoom in, zoom out and then
Yeah.
zoom in, because
Okay.
it's not very
Yeah.
comfortable without mouse.
Yeah, yeah.
I mean,
Yeah.
I can bring you a mouse.
There was one mouse with
Yeah.
the computer.
I will bring you a mouse.
Yeah, yeah. Okay, yeah, I always forget about that. So yeah, it's these things are much better done if you have a real mouse. Yeah. So I'm sorry I didn't prepare this in advance. I just because I didn't sleep yesterday at all. I slept well today, but woke up a little too late and forgot I needed to copy this. But like I said, you can ask me questions or you can just play with the graph, experiment with the colors, for example, because okay, you can of course create. Let's
While Yishi is looking, I can actually make a comment
Yeah.
that I think all of you registered, all of the present, you are interested in art as well, and it seems in my list that you overlap. So if Yishi is fine with that, we can somehow combine it, like we make a break, and then at around 13:30, right? Yeah, 13:30. We won't need to repeat all of the stuff, so we might expand this a bit and then slowly like move to the art part. So it will end earlier. What I mean to say, because VFX you need both in art and in scientific visualization, and we already like played with VFX a bit, so most likely we will end slightly earlier due to that.
Yeah, okay. I will share a file through Telegram, but I'm not sure if the file will work straight away. I hope it will, but it will take me some time to reopen everything on the laptop, which died. Okay, even opening Telegram now takes time. So, okay. Do I have anything? Come on. Okay, so some theory about setting the position of particles for our scientific visualization purposes. Like I said, if you have some particle data, we can, and you have the positions stored in some file, then we can directly set the position of those particles instead of doing some random operations in the VFX graph. Here, we would connect this this position variable to something. Now, this something is a little bit more involved than just generating the position through a script. And the reason for that is that the scripts which are running here in our scene, the scripts which are on the game objects, those are executed on the CPU, but the VFX graph is completely executed on the GPU. And this is a very general problem in scientific visualization of large data, and that is, and in computer games as well, and that is that whatever is in the CPU is kind of slow, whatever is on the GPU is very fast. and you want your visualization, especially if it's a lot of data, if it's large, you want. Yeah, I don't know. Probably. So if it's large, then you want it to be rendered fast. So you want to put everything, if possible, you want to put all the data on the GPU and only process it on the GPU. Because, okay, GPU is fast, CPU is maybe a little bit slower, but there's one thing that's like super slow, and that's transferring data from the CPU, or actually from the memory in your computer, to the memory of the GPU, of the graphics card. That's the slowest operation in the whole pipeline. So every time you do any memory copy operation between the CPU and the GPU, you completely killing your performance. It's just gonna be super slow. I mean, you can do it in some special ways, that, for example, you are working with some data on the GPU, you are displaying the data on the GPU while you prepared something on the CPU, and at the same time as you're displaying your data set A, you're copying the data set B to the GPU, and when it's ready, you switch. Now, this is the reason why we cannot really generate the positions here and input them here, because that's similar to copying the that means we either have to copy the data, or yeah, I mean, you cannot directly influence the running shader graph from the CPU if the shader graph is running on the GPU. So there we need to find some other way. Yeah, we need to find other way to get the positions into here, and to get all of them at once. Because again, if I just create a new node here, and a node that would lead me to a vector on the blackboard, so we've created those the floats on the blackboard, but of course we can also create a vector the same way we create a vector called a vector position, and now if I connect this position vector here, I can modify it from the outside, I can modify it from the inspector, but it's always just one number. So after the particles are respawned, they will all be at the same position. And there's no way to change the position from the script, from the outside, so that the position would be different for each of the particles. I mean, it would, but kind of like randomly. You cannot synchronize it. You cannot say particle 1, particle 2, particle 3. You can slowly modify the position, but it will just slowly change in time, and that's not what you want, because you might spawn 10 particles and at this position, then the position changes, and maybe there will be no particles in that specific period of time. And yeah, like I said, in general, this is not what you want. So what you want is to get all the positions at once, and copy the list, some matrix which contains the positions, and copy that matrix to the GPU at once, and then read the positions from that matrix. And this matrix has to be of a special kind, because it has to be in a format that's readable by the GPU. And it turns out that this format is a texture. So a texture normally is a picture that you could use, like we had here, for example. We use this this checkerboard texture. So you see that our particles are not they don't have a single color, but none of the computers like me today. This one starts stuttering as well. I mean, yeah, it's visible somehow. You see the checkerboard, yeah. Those two are darker and those two are lighter. So if I had some other texture, you just like see the picture of the texture on the top. And this texture, so that's the usual way of using textures to give some colors to give the visual to the object. But the texture, in theory, again, is just a bunch of numbers, because a color is a set of 3 or 4 numbers. So I can put some different numbers in there and manipulate the texture using the visual effects graph, so that the results of those numbers are not affecting the color of the resulting pixels, but they're affecting some other property of our visual graph particles. And in this case, we will use this texture to modify the positions of the particles. So I have opened Telegram successfully on my laptop, and I will send you a file that is already a compiled texture made out of some scientific particle data. I just need to find where it was. Rock Unity KU. Texture KU and particle positions. I hope this will work. So you should see a file in Telegram. So I open Telegram, go to here, scientific visualization, download this asset file, no, download, save as. I can save it directly to the assets folder of our project. So I found our project on desktop. I had it on desktop. Okay, day 1, and under assets, I save. Is this the? Okay, I'll save it, and it should, yeah, and it will appear here. So you see, there's a new file called positions. And if you would enlarge it, I don't know if it's possible here in the inspector. I don't know. Oh, no, this is something else. Reset this to 0 if you touch it as I did. Okay, you cannot enlarge it. But if you look at it closely, you see that it looks like some kind of periodically repeating color shades, and that's just because this file actually contains positions. So this visual representation as colors makes no sense. But to the computer, it doesn't matter. It's just a bunch of numbers, and its usual way to display it is to display it as positions. The format of this file is a texture, and here in inspector, it also tells us that it's a 2-dimensional texture. So the type of this, the type of this object file of the asset is a texture 2D. That's important because this is what we will then be inputting in the VFX graph. The texture 2D, but the thing is that the size of the texture is just like 128 by 1. And we know that it's because we have 128 particles stored there. So we will go back to our graph. And here, when setting the position, I delete those random numbers. I delete this the connection to that position, the position property, and instead on my blackboard, I delete this, and I create a new variable, and now or property. Now the property will be of type texture 2D, because that was the type of my input data now. And I rename this to, for example, position map. And you see here, it says that my position map will be some texture 2D. We don't put any default value in here because that doesn't make sense to us for now. And it will be exposed because we will be adding the position texture from outside, from the scene hierarchy window. Now we want to use the position map somehow, and you see that there's the connection points are color coded. Yeah, so the light blue ones are floating point values. The yellow ones are 3D vectors. But what are the red ones? The red ones are textures. And you probably guessed that you cannot connect a texture to a 3D vector. It will tell you the input and output have incompatible types. So we will not be using this way of setting the position. So I will select and delete this block. Instead, I add a new block, again, space, and I want to set a position from a texture from a so-called position map. So let's look if there's something that can help me. I search for position, and here in the list, I find the operator called set position from map. And if I add this set position from map, there's some default attribute map. That's what we've seen in the textures, and that's noise. So that's some random pre-generated two-dimensional texture that is just random noise. We don't want to, and yeah, while I'm doing this, okay, I'll return back so that you can see the immediate effects of what I'm doing. And so, okay, and I'll do it again. I close the blackboard, and okay, like if I turn it off, then there's this there's point in the single position. I turn it back on, and now they're scattered according to this attribute map, and that was just some random noise. But what I want to do is to connect our own position map here. And now the particles are actually being put into position defined by my position map. But okay, you don't know what the input data should look like, more or less. I do. I can show you so that you know kind of like, so this data, it's the position of atoms in a crystal. So it should be on some sort of a grid. And it's actually the same data I showed you at the very beginning, the one from those electronic structure in crystals, quantum mechanical calculations, and yeah, it was this one. So yeah, it should look something like this. The particles should be aligned on a grid, but they're not. And why is that?
So
well,
this is crystal structure, basically.
Yes, this is crystal structure. Those are the positions of the atoms inside the crystal, but it's not at time 0. It's already at some later time. So they will not be precisely aligned. They are already moved from their initial positions a little bit. Why is that? Well, the reason is that we're spawning not enough particles. We don't even have enough capacity to display all of the particles, because you've seen from the size of the again, if I go to inspector and click on my positions map, the size was 128 by 1, so I have 128 particles, and I need to display them, all of them. So first I need to change the capacity to 128. Now they're being spawned on with a constant rate of 16 particles per second. I don't need that. I know I have 128 particles, and I want, in my case, I will always have only 128 particles.
Can you please remind, how did you add the text on the blackboard?
Oh, yeah. Okay, so you go to the blackboard, open the blackboard, then there's this plus button, and you click plus, then you find texture 2D, and yeah, then you can give it a name and make it exposed from the outside. And then, okay, I save it, go to the inspector. I didn't even connect my position map. I go to the inspector, VFX1, to the visual effects graph, and put my position map in here. So again, sorry for the chaos. So we created this block, set position from map. So I put space and find set position from a map. On the blackboard, we have this position map, which is of type texture 2D. And I connect the position map here to the attribute map. Go from here to the attribute map of the set position map. Then I need to go to the inspector and open the VFX game object, which is living in the scene. And on the game object, I have this visual effect VFX1, or however you called it, and this has the position map connected, or like the property of a position map where I can put my position map directly like this, drag and drop. Now my particles are being placed according to the position map, but still there's some stuff which is not really well suited for scientific visualization. So for scientific visualization, we probably don't want this random spawn rate. We just, because we know we have 128 particles, then we just spawn 128 particles at the beginning. They will not have a limited lifetime. They will just be there forever. And so instead of the constant spawn rate, I can delete that and press space. And under spawn, I select single burst. So that's yeah, that means that it will just generate the particles at once at one point in time, and I know that I want 128 particles. I need to have enough capacity for that. So I put 128 here. Yeah. And with the with the burst spawn rate, there's another thing that is, if I reset the effect now somehow, will it not? The single burst needs yeah. This single spawn burst needs to be told when it should spawn the particles, whether that happens at the beginning of the game or if there's some trigger using which the particles will appear. So that's something you connect here to the start property. So I make a connection and add an event, and the event will simply be on play. That means at the beginning of the game, on play, there will be an event sent to the spawn system, and it will tell it to spawn the particles. Another thing I need to do is to remove this lifetime setting, because I want my particles to be there forever. So I just disable it, or I can like completely delete it. And now my particles are here forever. I have 128 of them, and their positions are set according to the to my input data, to my position map. Now maybe I don't want them to be displayed as cubes, because that's kind of unnatural for the particles. So I will probably display something else, as a sphere, for example. Their sizes are still random because I don't have any other data for the particles. I could make some data, so with, for example, some charge or something like that, and that would be again a texture. And I don't know if I can change the color of the texture from here. I will give it a try, because otherwise I would be setting the color from the map, but I only have this prepared for the volume data, not for the particle data. But let's try. Well, yeah, it works. So again, with space here in the output, you can set color. So you find color, and the attribute set color, and give it some color lighter, and yeah. Now you can see the underlying texture. There's still this checkerboard somehow, and the color doesn't have an alpha channel. Even if in the blend mode we had an alpha channel. Why is that? I'm not sure. Yeah, okay. We can set the alpha separately. So we find alpha, again, space, alpha, set alpha. Now alpha is set to 1, so we can set it something like 0.5. Now the particles are partially transparent, and now we recall. Now let's just play with the graph a little bit. So how is our scene looking? Like, this is our player object, and the particles are like somewhere here, pretty small. The position can be easily defined here by the position of the VFX object. So we drag it somewhere where we can see it better. And maybe we want to make this whole thing a little bit larger. So there are different options how to do that. Of course, we can scale the whole game object. That's one option. But let's not do it like that, because then it's kind of difficult to keep in your head what are the actual size relations of all these things, because then the coordinates inside the VFX graph are completely different from the coordinates you are using in the rest of the scene. So let's keep the scale at 1 and instead change the size in the VFX graph. How can we change the size? We can do it from the position map. And yeah, here's the value scale. So if we input the value scale, no, how is that so?
Yeah, it works.
Yeah, it didn't work for me.
You should press save. Oh,
I need to save it. Okay.
but
Yes, okay. You've probably noticed that working with the VFX graph is kind of like different. That yes, sometimes if you don't save it, you don't see the result immediately. Sometimes you do see it immediately, and this will be even more confusing when you work in play mode, because if I go to the play mode now, hit play. It will be compiling the shader graph. That's in general kind of like a expensive operation, so it may take some time too. And now you will see, okay, now of course it's using the mouse for both navigating the scene and navigating the graph. And now we will see that, for example, if I change the color here, it changes immediately. And even if I stop the play mode, the color stays. That's different than when we were editing the game objects in the inspector. So these changes are persistent because the reason is that you're not modifying the scene, but you're modifying the VFX graph, the graph itself, and that's an asset. It's not a attribute of the scene hierarchy. So it just like works a little bit different than the other stuff. Okay. So this is the way to display particle data. And I don't know if we should. Okay, any questions for this part?
Would appreciate if you see what's wrong, because when I start adding events and everything, it stopped showing.
Yeah. I mean, just
Yes.
one comment about the VFX graph in general. Like I said, first, it's kind of like I wouldn't say experimental technology. It's already been here for a couple of years. The idea itself isn't new, like this doing this programming in this visual way, using those visual graphs. That's not new either. But since Unity is evolving at a very fast pace, the VFX graph system is also evolving at a very fast pace, and sometimes it just some things just don't work the way you expect them to work, and since it's a combination of some very high level description of the algorithm, this visual description of the whole algorithm, and at the same time it has to communicate with the graphics card on like the really lowest hardware level. It's difficult for time consuming for the graphics card to do all the calculations needed even to convert this visual graph into some format that can be understood by the graphics card directly, and sometimes things break also in due to the interactions with the graphics card drivers. So very often, like, you have to, I don't know, reinstall the drivers, sometimes reinstall everything because something broke and is completely broken. There's like, it happens all the time, so don't be surprised if something doesn't work the way you expect it to work. Okay, so now please show me your screen and we'll see where's the problem.
So it is. So this is the pipeline, right? So this on-play event is added.
Yes.
Count like this, single
Going in a
burst.
single burst, yes.
Yeah, then let me move somewhere somehow. Initialize participle, also correct number, also this position map here, yeah, connected to attribute map.
Mm-hmm.
Then it tells this guy, oops. So it's kind of such.
You're without the mouse as well.
Kind of, yeah. So
I don't know. Can you try Googling if there's some other way to move in the position?
You can only zoom in and then
Really?
zoom out.
So this like lifetime is also deleted, yeah. Whatever it was, kind of.
That's the quad display, okay.
Yeah. And I didn't know how to get to that. And those were some examples, so it's not relevant. So
yeah, I mean, you can completely delete this block, the output block. And yeah, you can hide the blackboard. That might make it easier for you. Yeah.
I found, to make it easier, you can hold Alt and then you can move around with left click. Try holding Alt button and moving the thing around. Just zoom out so that you see it actually, yeah. And try with you hold Alt and then you hold left mouse button and you move around.
Left what button?
Left mouse button.
Okay.
Alt. Hold Alt. Press left. Yeah. Like this. Yeah.
Oh, wonderful. Yes.
Yeah.
Yeah.
Okay.
That's nice.
Okay.
So whatever it is, some random numbers. So I'm removing this out, whatever it is. Update particle. We don't need it, right? Or do we need it?
Yes, no, we need it. Even if it's not doing anything, I think you cannot like skip the parts of the pipeline.
Okay. So
But now after update particle, just go and click on the empty circle at the bottom of the block. Yeah. Drag, release the button, and now choose whatever you want. You can we did the mesh, so output particle mesh.
Yeah, like this. Okay.
And for the mesh, you need to change the main texture at the bottom.
Mm-hmm.
Yes. And click, no, click on the, when changing the main texture, don't click on the name, but on the right, on the circle, yes. Then scroll down, there was this checkerboard, so more. And or like
Let's select
go to the
anything,
search,
like
go to the search, yeah,
Mhm.
and put
Cube.
checker, check.
Sure.
I think it's yeah, and get the default checkerboard, the white one. Yeah,
This one.
yes, okay.
Mhm.
So, okay, can you go up in the graph? Just show me what's the rest of the pipeline. You can move with the yeah.
Mhm. Almost there. So how to move to the left? Yeah, like this.
Yeah.
So
So
system.
initialize is the second step. So spawn is the first.
Yeah, I
spawn
have it, but
system. Yeah. So drag this to the top, so we can see it better.
this,
Spawn system.
this, this.
Yes, that's the start of for the spawn, and then this is the position map, and down. So we can do position maps, number of particles. Okay. Go up, please. Disable the velocity. Set velocity random per component because we don't want the particles to move at all. Yes,
Okay.
yes, like this.
Okay, good. Now I start
And
having
I
this.
think
Okay,
it's
good.
already there, right?
Yes,
So
yes, there.
now you can also scale it so it's a little bigger. So you can do this from this set position from map. At the bottom of the set position from map, there's this value scale. And
Well,
yeah.
value scale, is it on which block?
Again, please.
Where value scale is located?
Oh, the value scale. It's in the set position from map. In the initialized particle, the last
This
part of
one.
initialized particle. No, up. Above update particle. Yes, here in initialize at the
This
end.
one.
The last value. Yes, value scale.
Okay, so make it like 2 or
something like 2 or 3, and yeah. And to see the result, you will actually have to save the graph.
Yeah.
So on the top, you can click on save, and
it's happening. Good. Thank you very much.
And
But also you want to change the mesh from I think you have capsules.
Yeah, you have capsules in the
change
mesh.
it to spheres, for example.
So yeah.
Like it can be artistic vision. It's
Absolutely.
completely up to
Yeah.
you.
So if you go to output particle mesh,
This one.
down.
No, it's this one.
Yes. And the mesh, the mesh parameter. Click on the circle to the right again. Yes, yeah. And select the sphere, for example. Yeah, that makes more sense for particles.
Yeah.
Yes, and now your particles are little spheres.
So my problem was velocity, I guess. Yeah, and something else. Okay, thank you very much.
Okay.
You can better.
So
Okay,
now,
thank you.
now Now, if we run our game, again, with the particle graph, it usually takes some time to compile and initialize, and we see our particles here. So we're almost done with the lecture part of the workshop, because now we know how to get particle styled data into a VFX graph, and now it's basically just up to you to choose your visual representation, and we can also find some ways to add some basic interaction, like when you're walking around, you can like change colors or like move something around, etc. The other things I have prepared, and which I think I can still show you. When do we end?
Sorry?
When do we end again?
We are supposed to actually, since we continue with the same group, like it's same people, even though it's switching to art, I would make a break now, like half an hour.
Yeah.
And then we continue. We can finish a bit with this. And
Okay.
We still will have 3 hours for art, which we won't use all.
Yeah. So just the other stuff I had prepared and was the volume data. I will show that because volume data is somehow different, because that's a 3D texture. Now the particle data you've seen, it can have, I have 128 particles, but it could have been any different number. With the volume data, that's a fixed grid, fixed 3D mesh, and that has the set number of nodes and or cells, and those cells will be rendered in a sort of kind of like a different way. That's one thing. And the last one was what was that? Oh yeah, animating the data. As like, so with the scientific data, the animation will not be generated by Unity, but you probably have a bunch of snapshots. For example, for the positions, I don't have just this one single texture I've sent you. You see the file is called position 99. So yeah, there's another 98 files with the positions at different time points. And like I've said, there are many ways. So I have different textures, and we can somehow exchange the texture. And by exchanging the texture, the positions will change. And this can be done in, again, many different ways. If you are really into speed, you would turn this position texture into multi-dimensional and just get slices, upload it on the GPU at once, and then just slice it. But that also means that you would be limited by the amount of memory on the GPU. What we will do here is that thing I've said you shouldn't be doing, and that's copying the texture from the CPU to the GPU. But in this case, it will be okay for 2 reasons. One reason is, in principle, I'm working with data that is so huge that it won't fit in even the computer RAM. It's several tens of gigabytes, like 100 gigabytes, and that 100 gigabytes lives on the hard drive. I need to load it and send it to the graphics card. But at the same time, if I start at frame 0 is displayed, and it's displayed until frame 1 is loaded. But this scene is alive. It just waits for the hard drive to load the next frame. So the animation might get a little bit choppy in some sense, but it's not slowing down the game. It's slowing down the animation of your atoms, but looking around the scene works completely smoothly. So you will see later. It doesn't really matter. It still works quite fine. So volume data and animation, and that will be everything I wanted to say about the scientific visualization part. Maybe slicing the volume data, but the rest will be up to you. We will probably create, maybe we will create a completely new scene, and you can play with the ways you would find your own ways to visualize this data, to modify it through the VFX graph. I will of course show you some examples. So that's one thing, one way we can continue with the workshop. And the other way, of course, is if you have your own data, we can try to find ways to convert your data to textured data and work with that. And like I said, the last part would be like more individual work, because I cannot do everything at once. So some of you will do the VFX graph, some of you will try to write scripts on for converting the data, and I will just help as necessary. So is that okay? Sounds like a plan?
Yes.
Great. So we make a break. And
My apologies. May I ask a few questions before
of course, please, yes.
Yeah. Sorry, so I missed because of some work and activities. Like yesterday, completely, unfortunately, part of the first class. Can you hear me well, by the way?
Yes, yeah.
Good, thank you. So at first, why I decided to go with Unity instead of Unreal?
Okay, good question. Yeah, I think Unity is easier to learn for the beginners.
Because of these blueprints, or
sorry?
Because of the blueprints, like visualization of the work with different components.
That's one thing. So this hierarchical style of creating game objects and attaching components, where each component is a separate script. In the like the easiest way to explain that, I think this is easier than in Unreal, where the object hierarchy is kind of tied to the C++, to the underlying C++ program that basically represents an Unreal scene. So here the C# scripts are more like, in certain sense, like more like individual disconnected entities. So instead of building one large code system, you are just like amalgamating from kind of like independent modules. That's one reason. The second reason is that and that's just my personal feeling, that the assets available in the Unity asset store, the plugins, the pre-made plugins, that there's more of them and than for Unreal. The other thing is that it's way easier to do virtual reality with Unity than it is with Unreal, and that's it basically. But like in general, you could do all these things in Unreal. I'm not sure if Unreal has an equivalent of the VFX graph of the part I've showed today. I don't know. Maybe it has, but not sure about it. But otherwise, yes, in principle, they are basically equivalent, and you just learned one or the other. I think, and like I said, I think that Unity is easier for the
okay.
beginners. There's also I don't know what's the licensing conditions of Unreal. I think you can get some sort of free personal license, and
Yep.
maybe even yeah, and you can even like publish with that free personal license. I think somehow I think it's similar to Unity. Here you can publish with the free personal license, but you have to be a part of a company that whose revenue is less than $100,000 per year. If your revenue is more, then you need to buy some license, and the price of the of that one was something like $1,000 per month or per year. Per year. I don't know. Like, and I think Unreal has some sort of like similar licensing scheme. So if you're doing it on small scale, then you can do it with the free version. I think they will also be open to giving like educational licenses if you are in a in educational field, and then there's a completely free open source game engine called Godot, and it has, of course, it's not as advanced as either Unreal or Unity, but in a way it's similar. Again, it has a completely different approach to designing the scene, or like the hierarchy of objects in your scene. But in principle, you can also use that. And I think Godot is the most difficult one to learn for the beginners. But again, the plus side is that it's completely written in C++ and it's completely open source. So you can modify any part of the Godot engine if you wish, and and it's free. So that might be that might be a reason for someone to use it. Personally, I use either Godot for some open source projects or Unity. And while I know Unreal, I don't use it because, I mean, if I need to have something done fast, and if I want to experiment with the newest graphics features and things like this, and if I need to, for example, use hardware which has the difficult support on Linux, or like in general, if the hardware even have some like weird drivers for Windows, then I use Unity because it's easier to get all this interaction right. Otherwise, if it's like a long-term project and I know exactly what kind of hardware I'm using, I will use Godot, and especially if I need to communicate with some external service. So, for example, if you want to do like live visualization of some computation running on a cluster, then you need to modify some parts of the engine, then I would use Godot. Otherwise, I would use Unity. But Unreal is, I would say, a completely equivalent option. It's just like you usually use one or the other, not both at the same time, because both have their specifics, both take some time to learn. But otherwise, like I said, I mean, like even in regarding the user base, those two are basically equivalent. You have three major engines. That's Unreal, Unity, and the Source engine from Valve. But I'm not sure. I think Valve that the Source engine is not like available, or I don't know. I don't think it's available for free. So if you're starting, I'm not sure. Maybe it is, but I think that if you're starting, your two viable options are Unreal or Unity, and yeah, Godot if you're adventurous.
Yeah, thank you for this answer. So on the first class, you shown this camera. Yeah, could you please share somewhere its specification?
The specification of the
What
3D camera?
Yep.
Yeah, okay. I'll send. I'll show you the. It's called OGD Pro. OGD Pro. Yeah,
Mm.
and I'll send the link to the Telegram group.
Okay.
Wow, okay, you're using it here, so why not?
Yeah, thank you.
If you go through their shop, so this I like this one because it has this active stereo laser dot projection, and it has night vision, and also it has a good resolution. So for the because if you do an artistic installation in a gallery, it's usually dark in the gallery because if I mean our artistic installations are usually also combined light sources like uh, mm, uh, yeah, you've seen that light sculpture, or we using many old we have bought like 30 old computer monitors, like good ones, ASOS, but the price for one was something like $20. So it's like we bought 30 of them, and or we use projectors. And when you do an installation with a light source, then you usually do it in a dark gallery. And but then if your camera it doesn't have night vision or like active any way of active dot projecting, then it's very difficult to get a good stream out of it if it's dark. So that's why I prefer these. They have I don't know what's this last version, but they have those two versions, autofocus and fixed focus. We usually use fixed focus one, but fixed focus has focus. I think the minimum is something like 50 or 80 centimeters. So if you're closer, then it's not being focused. But that's because we need to see the whole scene at once. If your use case is just on tracking a single object, then autofocus might work better. Yeah? And the prices you see like $350, but there's also a different version, a smaller one, which is called OGD Lite, and OGD Lite is only $150, but it doesn't have light vision, so it's night vision. So it's just or like active laser projection. So it's only a stereo camera. So you need a well illuminated scene in order to get a good 3D image. At the same time, it's not just two cameras. It's more. So it's a stereo camera with a RGB camera and with a specific chip inside the camera, and that chip already does this processing. So you can see it has this four tensor operations per second processing power. For tera tensor operations. So you can some of the algorithms are not being run on the computer but directly on the camera. One of them is actually getting the depth image, and there's many others which you can see if you take a look of the drivers for the camera. It's called Depth AI, And so if you get to Depth AI's documentation, you can see the Depth AI SDK, amazing example use cases. Yeah. So this is all the stuff that it can do. It has like object recognition. It has hand tracking, pose estimation, license plate recognition, gaze estimation, in like I'll send a link to this as well.
Okay.
Those are the drivers, and the examples are partially run on the camera itself. The important thing here, what it means is that you don't need a fast computer to do these things if you have this camera. So you can buy a small single board like a Raspberry, connect that camera to the Raspberry, and do object recognition with a Raspberry Pi. Which like there's a you cannot do that on Raspberry itself. It's just impossible. It's not fast enough. So this is one hardware piece that gives you both the vision and the AI. All those. I mean, like go through this website and look on all the examples and all that it can do. Of course, you can upload your own trained neural networks onto the camera and then do your very specific task. But I think you can think of many different interesting uses for that. And you can do this even with this cheap camera. If you don't need night vision, if you're just operating during the day, then the price is $150 plus a Raspberry Pi, which is like what, $30 or $35 for the 8 gigabyte version, I think. They have even smaller modules. Some of those W ones are for wide angle vision, but they don't see that far away. And some of them, yeah, they're powered by USB-C, but you can also buy versions which are using power over Ethernet cable. Those are like for industrial applications to be put outside. And yeah, these small ones, these are not stereo cameras, so they cannot run all of the algorithms, because some of the algorithms need this depth sensing as well. But for example, for object recognition, you're fine. If just what you need is just object recognition, you can do this small camera. So it's not just the camera, it's the camera plus the tensor processing unit. And you can also have them, you can also buy them without the case. They used to advertise it here. Maybe they don't advertise it anymore, but if you need it, if you want to mount it on your own specific hardware, you can order it without the case and just as the camera itself and the board.
Okay, thank you.
Yeah. So any other question?
Yeah, so I have two actually left.
Yeah.
The first one is, so could you please send this blueprint file which you created over this class? I mean, for Unity.
You mean the project that we made during
Yes,
the workshop?
exactly. Yeah.
Okay. I can do that. Okay. So,
yeah, the reason that
while you're here, I can also show you how to do that, because that's something good to know.
To export it.
Okay. Maybe if you have the other question, then I will show it after the.
Okay, sure. And another one is, so as I understand, in order to be imported to Unity, data should be transferred to this texture format, right?
Yes.
And so are there any maybe technical restrictions, maybe like number of
For the texture?
amount of RAM or like memory on the video card? So maybe some kind
Yes.
of hardware limitations.
Yeah.
I
Okay.
mean, to work with that. Because
So
if I
the
have like
textures.
40,000 of numbers in my data set, for instance, I believe that it would be some kind of difficult to work with such amount
How
of
much did you say? 40,000?
14,000.
Yeah, that's okay. I mean, if
Okay.
it's under a million, then it's usually okay.
Okay.
So yes, the limitation is, as you guessed, the main limitation is the memory of your graphics card. Yeah, because if the texture won't fit the graphics card, then there's no way to display it. And the texture itself, there's many different formats for the textures. So the most typical one is the RGBA. So the texture, each element of the texture has those four elements, and each element is 8 bytes. So RGBA 24 is the most common format for the texture. But so, for example, if your data is if your data is won't fit into a float, for example, if you need a double to represent some elements of your data, you either need to convert to floats or you need to use some higher precision texture format. And sometimes, though, the precision is sometimes your graphics card won't support that format. So you actually have to do this low-level thing of splitting your number into two and then recalculating, like recalculating the number back in the VFX graph. Sometimes that happens. You can look up in Unity texture formats. Unity texture formats. There's this recommended default and supported formats by platform, and that's the thing you will encounter, that different platforms, different drivers have different like not everything will support all the different textures. So sometimes you might find the texture that's perfect for your use case, but you find out that it, for example, doesn't work on Android. Yeah, so you have to choose a different one. But yeah, so I'll send this link to the Telegram channel as well. We will be using RGB24 or RGB232, and that's something that's supported on all of them. But it might not be enough for a specific use case, and then yes, then you'll need to be finding some workarounds. The texture itself, like I said, it's just a matrix, a 2D matrix or a 3D matrix. So whenever your data is representable in a 2D or 3D matrix, you can convert it to texture and then work with it in Unity.
And is there a script or some kind of maybe an approach to convert this data? I mean, maybe
yeah.
this
This will be a part of the workshop, actually. I will show some of these scripts, but like in general, either you have a script that converts to some conventional texture format, but like, I mean, a conventional texture format is, for example, a PNG file. Yeah.
Okay.
So if you can export a PNG file, then you're fine. But if you have, for example, data in some sort of text format, that's what I will show. Then you just write the script yourself. I mean, it's not difficult, but like the problem here is that with scientific data in general, is that we don't work with textures. Yeah, we have our own formats. We use HDF5. But I mean, if you're at a scientific institution and your group uses HDF5, then it's great. Like most of them, I would say, still use some custom, completely unknown formats. And so some people, for example, work in MATLAB, but that's great because MATLAB is just like text file with columns, and the delimiter is just a new line character. The same goes for this cube format I advertised, and I mean, a cube is a completely obscure format. But the nice thing about it is it's again a simple text file, and a lot of other text formats can be converted to that one by just adding some metadata. And from those, and I have the reason is I already have a converter from cube to a texture, so it's a nice example of how can you convert text data into a texture.
Okay. Okay, so will it be presented today or tomorrow?
Tomorrow.
Today we will make a break. I think
Okay.
even 40 minutes.
Yeah.
So we will continue at 14:30. Is that okay with everyone?
At 14:30.
Yes. I thought that we will grab the pizza, like have some lunch.
Well, yeah, okay, that's a good idea.
So
let's have
we
lunch.
plan to continue at 14:30, and we will move to the art session of the workshop, like beginning of the art.
Yes.
Like how to scan, and well, you know better what you want.
Yes. You'll use the 3D scans, etc. But and then the scientific part continues tomorrow.
Yes.
So yeah, if you want to attend the art workshop, do you want to attend it too, or do you want just to continue with the science workshop?
Is the question to me?
Yes. Sorry.
Yes, I'll try, but I will be mainly as a passive listener due to some more work I have. I mean, I need to participate in other meetings, but yes, I'll try to listen, you at least.
Okay.
I see that Katerina Semina connected. She was interested in art workshop, and we planned like science and then art today.
Yeah. So yeah, we will continue with that tomorrow, and I will show those ways how to convert the data, and yeah. So if you can connect tomorrow, it would be the best. Just we're just do it according to the original schedule, and
yes.
So yeah, is that okay for you?
Yeah, sure. Thank you. Thank you for your time,
great.
for these explanations.
Okay, so see you all after the break. And oh, Katerina has connected. Hello, Katerina. I don't know if you've heard that, but
hello.
Hi. We'll actually taking a break now. So because yeah, so you can connect in. We said what?
I'd say in 45 minutes.
In 45 minutes, yeah.
14:30.
Yeah. But while you're here, did you have a chance to try the Unity basics at least?
No, I haven't checked the previous lectures, but I'll try to check it today. But now I will listen and try to understand what is going on.
Okay. Okay, so let's hope it won't be too difficult. I think it won't be too difficult. Okay, so see you in 40 minutes.
Thank you. Bon appetit, by the way.
Thank you very much. Bon appetit to you as well if you're going to lunch too.
Thank you.
See you later.
Bye. Bye.